Hello, my name is Daniel, and today we'll be going through the AMC 12B from the year 2005, so let's get started. First problem, a scout troop buys 1,000 candy bars at a price of 5 for $2. They sell all the candy bars at the price of 2 for $1. What was their profit in dollars? Okay, so since they sold it for 2 for $1, that means each candy bar was sold at half a dollar, and they bought it at 5 for $2, which means that they bought it for, so they bought one for 2 over 5, right? So this margin is going to be equal to 1 over 10, right? And then they had 1,000 of those, so they had 1,000 times 1 over 10 equal to 100. So this is the answer. It's A. Number 2, a positive number x has the property that x% of x is 4. What is x? Okay, so since x% of x is x times x over 100, because this is x%, this equals 4, so x squared equals 400. X equals 20 because x is a positive number, so it's D. Number 3, Brianna is using part of the money she earned on her weekend job to buy several equally priced CDs. She used 1/5 of her money to buy 1/3 of the CDs. What fraction of her money will she have left after she buys all the CDs? Okay, so 1/3 of the CDs, these costs 1/5 of her money, right? So buying all the CDs, which is 3 over 3, this is going to be equal to 3 over 5 of the money, right? And so she's going to have 2 over 5 left, right? So the answer is going to be C. Number 4, at the beginning of the school year, Lisa's goal was to earn an A on at least 80% of her 50 quizzes of the year. She earned an A on 22 of the first 30 quizzes. If she is to achieve her goal on at most how many of the remaining quizzes can she earn a grade lower than an A? Okay, so since her goal is 80% of her 50 quizzes, 80% of 50, this is 40 quizzes, right? 40 quizzes, she has to get an A, right? And then she got 22, so she has to get 40 minus 22 equals 18 more A's, right? 18 more A's. So she has 50 minus 30, which is 20 left. So 20 left. And then at most, how many of the remaining quizzes can she earn a grade lower than an A? So minus 18. This is going to be 2. So 2 is the answer. It's B. Number 5, an 8 foot by 10 foot floor is tiled with square tiles of size 1 foot by 1 foot, right? So there's going to be 80 tiles in total. 80 tiles in total. And then each tile has a pattern consisting of 4 white quarter circles, so it's just that one. The remaining portion of the tile is shaded. How many square feet of the floor are shaded? Okay, so we want the shaded area, right? So that shaded area is the area of the whole thing minus the area of just one full circle, right? Because this is each 1/4 circle, and so they combine to get one full circle. And so that will give us, this is 1 and this is 1, so that's just the square is 1 minus the square, minus the circle, and the radius is 1/2 foot, so minus 1/2 squared pi, so this is going to be equal to 1 minus 1 over 4 pi. And we have 80,000 total, so 80 times 1 minus 1 over 4 pi, this is going to be equal to 80 minus 20 pi, right? So this is 80 minus 20 pi, the answer is A. Number 6, in triangle ABC, when we have AC equals BC equals 7 and AB equals 2. Suppose that D is a point on line AB such that B lies between A and D and CD equals 8. What is BD? Okay, so if we draw this as a diagram, we'll bring it up here. So this will be our diagram, and if we have A here, then this will be C and this will be B, right? And AC is BC is 7, so that will be 7 and 7. And then AB equals 2, so this that whole thing is 2. That means that's 1 and 1. And D is a point on line AB such that B lies between A and D and CD equals 8. So this is D. Is a point on line AB, and then CD should equal 8. So this is 8. So this is 8, and we want BD, so let's say that BD is X. And so now we can see 2 right triangles, this one and this one. And so since they all have this line in common, that means 7 squared minus 1 squared equals 8 squared minus 1 plus x squared. So if we just write that down, 7 squared minus 1 squared equals 8 squared minus 1 plus x squared, right? That's because of, yet again, this triangle and that triangle, right? So that gives us, this gives us that 49 minus 1, which is 48. 48 equals 64 minus x squared plus 2x plus 1, right? And so x squared plus 2x, this is going to be equal to 15. So x squared plus 2x minus 15 equals 0. X equals 3 or negative 5, but then since x is a positive value, x must be 3. The answer is 3. It's A. Number 7, what is the area enclosed by the graph of this? Okay, so since both x and y, they both have absolute values. These mean that the graph is symmetric about about the x and y axis. So x-axis and the y-axis. And so if we just draw this out, then that will become something like that. And then now let's say that when x and y are both positive, right? So when x is greater than or equal to 0 and y is greater than or equal to 0, then this is going to give us 3x plus 4y equals 12. So it's going to be so it's going to have 4, 0 as x-intercept and 0, 3 as y-intercept, right? And so this is going to be 4 and this is going to be 3. And so if we connect those, then that's going to be our graph in the first quadrant. And then since it's symmetric about the x and the y-axis, then it's also going to be like that, that, and that, right? And so to get this whole area, then we can just get this one area and multiply that by 4, right? And so the whole area, this is equal to 4 times, and then this is 3, this is 4, right? So this is 3, this is 4. So 1/2 times 3 times 4, this is equal to 2. 2 times 3 times 4 equals 24. So this is the answer, it's D. Number 8, for how many values of a is it true that the line y equals x plus a passes through the vertex of the parabola y equals x squared plus a squared? Okay, so if we draw that, then we're going to have x squared plus a squared, so we're going to have like this, and then this value is going to be a squared, right? And then y equals x plus a, that's going to be this one, that's going to be something like this, and then this value is going to be a, right? And then if this wants to pass through the vertex of the parabola, so exactly this point, then what we, and then the only way is for a to equal a squared. And that means a is equal to 0 or 1, which is 2 values, right? So it's 2 values. The answer is C. Number 9, on a certain math exam, 10% of the students got 70 points, 25% got 80 points, 20% got 85 points, 15% got 90 points, and the rest got 95 points. Okay, so subtracting from 100, that means this is 30%, right? And then what is the difference between the mean and the median score on this exam? Okay, so if we say that we have 20 students total, then that would mean that 2 people got 70, and 5 people got 80, and 4 people got 85, and 3 people got 90, and 6 people got 95. That's just dividing by 5, all of these percentages. And so this will give us the sum that 2 times 70, that's 140, 5 times 80 is 400, 4 times 85, that's 340, 3 times 90 is 270, and 6 times 95 is 570, right? And so if you add them all up, that gives us 1720. And so since we have 20 students total, our mean equals 1720 over 20, which is equal to 86, right? So so this is our mean. And to get our median, we since we have 20 students total, then we have to find 10th and 11th score when it's from lowest to highest, right? And so the 10th is going to be here, and the 11th is also going to be from here, right? So 85 is the median score. Median. And so the difference between the mean and the median, the mean is greater, so it's 86 minus 85, which is equal to 1. So the answer is 1, it's B. Number 10, the first term of a sequence is 2005. Each succeeding term is the sum of the cubes of the digits of the previous terms. What is the 2005th term of the sequence? If we just write this out, we have 2005 first, right? And then what this means is that we have 2005, so our next term is going to be 2 cubed plus 0 cubed plus 0 cubed plus 5 cubed, right? So that's going to be 133. And then our next term of that is going to be 1 cubed plus 3 cubed plus 3 cubed, which is 54 plus 1, that's 55. And then after 55, this is going to be 5 cubed plus 5 cubed, which is 125 plus 125, that's 250. But then notice the digits of 250 are the same as the digits of 2005, right? And so that will just lead us to 133, right? 133, because this next one, that will just be the same thing as this, right? And then so 250, 133, 55. So this cycle, 250, 133, 55, this is just going to continue forever, right? And so what we need to know now is the remainder of 2005 when it's divided by 3. And so 2005, 2005, this is 3 times 668 plus 1, so the remainder is 1. And so 2005th term is the first number of the three numbers that rotate, that's 250. So the answer is E. Number 11. An envelope contains 8 bills, 2 ones, 2 fives, 2 tens, and 2 20s. 2 bills are drawn at random without replacement. What is the probability that their sum is $20 or more? First, let's try to differentiate the 5s, 10s, 1s, and 20s. And so to do that, we'll just say it's 1A, 1B. That's 2 5s, so it's 5A, 5B. And then it's 10A, 10B. And then the 20s, we'll say 20A, 20B, right? And then for the sum to be $20 or more, we can just first get just both 10s, right? 10A and 10B, because that's just gonna be 20 exactly. And then the next possibility is when we have 20A and we have anything, because that's just obviously gonna be more than 20. And then the next is when we have 20B and we have anything, because that's also gonna be more than 20. But then here we have an overlap, which is getting 20A and 20B. Sorry, that should be 20B, right? So getting both 20A and 20B, that overlaps, so we have to subtract one of them. Subtract 20A, 20B, right? And so this whole thing is, we have one possibility, and then we add, we have 8 in total, and so besides this we have 7 more, so we have 7. Same thing here, we have 7, and then we have to subtract 1, right? Minus 1. These to cancel, this is 14. And so since we have 8 bills in total, but they are all different, right? We differentiated all of them. Yeah, so our total number of possibilities without considering this, that would be 8 choose 2, right? That's 28, right? And so our total probability is 14 over 28. So 14 over 28, this is equal to 1/2. So this is the answer, it's D. Number 12, the quadratic equation x squared plus mx plus n has roots twice those of x squared plus px plus m, and none of m, n, and p are 0. What is the value of n over p? Okay, so let's say that the roots of x squared plus px plus m, they are a and b. Then x squared plus mx plus n, that would have roots 2a and 2b, right? And so because of this, let's just first write out a plus b, so that's the sum of the roots, that's going to be negative p. And so p is going to be negative a minus b, right? So that's going to be minus a minus b equals p. And then the product of those two, so a times b, that's going to be m. So this is m. And then for this one, let me write some stuff. So the sum is 2 times a plus b. 2 times a plus b, this is equal to negative m, right? So 2 times minus a minus b equals m, right? And then for the product of the roots, that's just n. So n is going to equal 2a times 2b, which is 4ab. 4ab, right? And then what we want is n over p, and we can write both n and p in terms of m, right? Because of this one and this one, we can see that 2p equals m, so p equals m over 2. And because of these two, that means n equals 4m, right? So n over p is going to equal 4m over m over 2, which is equal to 8. So 8 is the answer, it's D. Number 13, suppose that 4 to the x1 power is 5, 5 to the x2 power is 6, 6 to the x3 power is 7, and all the way to 127, x to the 124 is equal to 128. What is x1, x2 all the way multiplied up to x124? Okay, so if we solve for x1, x2, and all the way to x124, that gives us x1 equals log 4 of 5, and x2 equals log 5 of 4, and x3 equals log 6. Sorry, that's not log 5 of 4, that's log 5 of 6. And log 6 of 7, log 7 of 8, all the way to log 127 of 128, right? So these are all just going to be log 5 over log 4 times log 6 over log 5 times log 7 over log 6 over log 6 times log 8 over log 7, right? And so on until log 128 over log 127, right? And so these are all just going to cancel, and so that's and so we are only going to be left with log 128 over log 4, right? Because that's just going to be equal to 2 log 2 over 7 log 2. This is equal to 7 over 2. So this is the answer, it's D. Number 14, a circle having center 0, k with k is greater than 6 is tangent to the lines y equals x, y equals minus x, and y equals 6. What is the radius of the circle? Okay, so if we just write out all of this, draw this as a diagram. So this will be, this orange one, that's our circle, and this one we have, that is y equals 6. This one we have y equals x, and this one is y equals negative x, right? Since k is greater than 6, it's not going to be this circle, and it's going to be the one that's bigger, right? And so if we set a k point here, sorry, yeah, so if we make the center that one, right? So if we make this the center, right, that will be the center of the circle. Then let's say that the radius is r. So the distance from the center to the radius, this distance is going to be r. No, let's do that in red. So the distance from the center to the radius, no, to the tangent, that's going to be r. And this and this length, that's also going to be r, right? And then since this is y equals 6, this length is going to be also, yeah, so that length is going to be 6, right? That's kind of by definition. And so we can see that this whole length, that is r plus 6, right? So this is r plus 6. Since this is a right angle, and this is y equals minus x, so that means that this is 45 degrees, right? And so that means that this whole triangle, that's a 45, 45, 90 degree triangle, and so we're going to have length ratio is 1 to 1 to root 2, right? So since the ratio is 1 to root 2, then that means that r plus 6 over r is equal to root 2 over 1. And so if you cross multiply, r plus 6 equals root 2r, root 2r, so 6 equals root 2 minus 1 r, so r equals 6 over root 2 minus 1, which equals 6 times root 2 plus 1, right? So this is equal to E. The answer is E. Number 15, the sum of 4 two-digit numbers is 221. None of the 8 digits is 0, and no two of them are the same. Which of the following is not included among the 8 digits? So let's say that the number that is not included, let's say that this is x. And then since none of the 8 digits is 0 and no two of them are the same, then our possibilities are 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So from these, 8 are going to be used and 1 is going to be discarded. And since the sum is 221, we can use the property that any number mod 9, this is going to be equal to the sum of, it's going to be equal to the sum of its digits mod 9, right? If we do that, then the sum of the two-digit numbers is 221, right? So 221 mod 9, this is going to be same as 5 mod 9. And then this is going to be equal to this much minus the discarded value, right? So that's going to be 1 plus 2 plus 3 plus 4 plus all the way to 9 minus x, right? And then this mod 9. But then we know that those values added together, that's just 45, right? So 45 minus x mod 9. But then 45, that's also a multiple of 9, so this is equal to negative x mod 9. And then since we want to get x, we can use the fact that this is equal to 9 minus x, right, mod 9. And so we can use the fact that these two are equal. So we can see that 5 equals 9 minus x. So x equals 4. So this is 4. The answer is D. Number 16. 8 spheres of radius 1 per octant, are each tangent to the coordinate planes. What is the radius of the smallest sphere centered at the origin that contains these 8 spheres? Okay, so first let's draw a cube, and I will explain why. So we have 8 spheres of radius 1 and 1 per octant, right? And so if we say that the center of everything, center of the coordinate plane that goes through here, then we can say that there is lines like that. So those are the lines. Just think that there is one sphere at each corner of this square, right? That would bring in something like this, right? And so these are the 8 spheres that are so that are tangent to the coordinate planes. So if we also we have the smallest sphere that contains these eight spheres, so we want the radius of this sphere, right? And then they should all be tangent, right? And so if we draw that a little better, then we will have something like this, right? Blue circle, this is so those are the spheres of radius 1 that are tangent to the coordinate planes. And so if we just make one more over here, then this would also be tangent to the coordinate planes, right? And then we want the radius of this big thing, right? But then to get that, we have to get the distance from here to here, so that's from one end to the other. And to do that, first we know this diagonal length, right? So since this is radius 1, then so that means that since we have like 2 spheres like that, that means those two will both be the radius. So that means we have 1 and 1. So we know that we have 2 on one side, right? So this is going to be, one side is going to be 2, this is going to be 2, this is going to be 2, right? And so that's going to give us this length, which is 2 root 3. Because if we have 1, 1, 1, then we have root 3. So if we have 2, 2, 2, then we will automatically have 2 root 3, right? And then also, for these values that are missing, obviously these are radii of the circles. This is just 1. And same thing for this one. This is just 1, right? And so the diameter, this is going to be 2 root 3 plus 1 plus 1, right? So 2 root 3 plus 2. And so the radius is going to be 2 root 3 plus 2 over 2 is equal to root 3 plus 1, right? And so this is the radius. It's d. Number 17, how many distinct 4 tuples a, b, c, d of rational numbers are there with a times log 10 of 2 plus b times log 10 of 3 plus c times log 10 of 5 plus d times log 10 of 7, which equals 2005? Okay, so first of all, let's just raise up all these a, b, c, d's up there, and so that will give us, it's log 2 of a plus log 3 of b plus log 5 to the cth power plus log 7 to the dth power. And so since these all multiply, that's just going to be equal to log of 2 to the 8th power, 3 to the bth power, 5 to the cth power, and 7 to the dth power. And this is equal to 2005, right? 2005, and if we just put back the 10, that means 2 to the 8th power, 3 to the bth power, 5 to the cth power, times 7 to the dth power. This is equal to, if this goes over there, that gives us, that is 10 to the 2005 power, right? And since 10 is only made up of 2 and 5, this automatically gives us that A and C, they equal 2005, and B and D, they equal 0, right? So this must be the case. So we only have one 4 tuple of A, B, C, D, and that's just that one. So we have one of them, so the answer is B. Number 18, let A 2,2 and B 7,7 be points in the plane. Define R as the region in the first quadrant consisting of those points C such that triangle ABC is an acute triangle, where is the closest integer to the area of the region R. Okay, so let's first draw the coordinate plane and the points A and B. So these will be it. So this is going to be A and this is going to be B. And so since R has to be where ABC is an acute triangle, then since we will have this length, so we will have this side for sure, and this side AB for sure. If we have any values of C being here, then that will be like that. So that won't be an acute triangle. And so to prevent that, we have to make lines that are like that, so that are perpendicular to AB, right? So lines that are perpendicular to AB. So this will be one more of those lines like that, right? That way, if we have triangle ABC like that, we won't have any C values going out like that and then making it an obtuse triangle, right? Or a right triangle like that. Next, what we have to see is that this C value, this cannot go like that. So this can't go too far inside A and B. If you see, the boundary is when this angle is 90 degrees, right? If you trace the curve for which the angle is 90 degrees, then it's something like this, right? Yeah, something like that. So you see that makes a circle, right? And so we need to have a circle that has diameter AB, like that, right? And so a circle of diameter AB, if we move it, so write that. We would have to be outside the circle, but then inside of these two lines, and then they have to be in the first quadrant, right? And so in total, our area is limited to this much, that much, plus this much, right? And so to get this area, it's just this area, this much, and then minus this much, right? So minus the circle. So first, to get that, this is going to be equal to 1/2 times 14 squared minus 1/2 times 4 squared, right? So because this is 14 and this is 4, this is 14 and this is 4, right? And so this is just this triangle minus this triangle, right? And so that will give us this triangle. So that will give us this area, right? And then Yeah, so this is for the, that's for the quadrilateral, and for the and for the circle, that will have to be subtracted by, since this is 2 comma 2 and this is 7 comma 7, yeah, and this is 7 comma 7, then we know that this length is 5 root 2, right? So the diameter is 5 root 2. That means the diameter must be 5 root 2 over 2, right? So that would be 5 root 2 over 2 squared pi, right? So this would be like that. And so this will mean that it is 180 over 2 minus 50 over 4 pi, right? And so if we do that, that will be 90 minus, and then 25 over 2 pi, right? And so this is 90 minus, this is 3, right? So this is 3. So this is going to be 75 over 2. So this is 90 minus 37.5, right? So this is going to be equal to 52.5. 52.5. So this is the answer. It's C, because that's the closest. Number 19, let x and y be two-digit integers such that y is obtained by reversing the digits of x. The integers x and y satisfy x squared minus y squared equals m squared for some positive integer m, whereas x plus y plus m. Okay, so let's say that x is 10a plus b and y equals 10b plus a, right? Because x and y, they are, yeah, so because y is reversing the digit of x. And so since x squared minus y squared equals m squared, we can just plug these in. That gives us 10a plus b squared minus 10b plus a squared equals m squared. And so it's 100a squared plus b squared minus 100b squared minus a squared, 99a squared minus 99b squared equals m squared. And so this will give us 99 times a squared minus b squared, which is a plus b, a minus b, and this is m squared. So that means that, yeah, so these two, they have to be at least 11, right? But then since a and b are single digits, that means these two have to be 11. That means a plus b is 11 and a minus b is 1. So a equals 6, b equals 5. A equals 6, b equals 5. And so that means that m would equal the root of 99 times a squared minus b squared. So 99 times 99 times 11, right? Because this has to be 11. This is going to be 33, right? And so x plus y plus m, that's going to be, x and y are going to be 56 and 65. So it's 56 plus 65 plus 33. This is equal to 154. So this is the answer. It's E. Number 20, let a, b, c, d, e, f, g, h be distinct elements in the set this one. What is the minimum possible value of a, b, c, d squared plus e, f, g, h squared? Okay, so first of all, let's try to get the sum of these numbers. So the sum is going to be, these two cancel, and then we have 8 and 10, so this is going to be 2 minus, and that's negative 5, so that's going to be sum of 8. So the sum of the whole thing is 8. That means that the theoretical minimum value, so this is going to be 4 and 4, so that will give us, this is 4 and this is 4, that's what I mean. So our value will be 4 squared plus 4 squared, which is 32, right? But then we don't know if that's the actual answer yet, because we don't know if that's actually possible, right? If you do it, 4 and 4, they are impossible, and the closest thing that we can get is 3 and 5. So this 3 is made by 4 plus 6 minus 5 minus 2, and 5 is going to be made by 13 plus 2 minus 3 minus 3 minus 7. And so these are possible, and so if we get these values, that's going to be 3 squared plus 5 squared, which is equal to 34, right? So it's going to be 34. It's C. Number 21, a positive integer n has 60 divisors and 7n has 80 divisors. Where is the greatest integer k such that 7 to the kth power divides n? Okay, so n has 60 and 7n has 80 divisors, but then the only difference between n and 7n, that's the number of 7s. 60, this equals 3 times 20, and 80, this equals 4 times 20. So 80 equals 4 times 20. So that means that these are the number of factors, right? And so if we want to go to the prime factorization of n, then we are going to have to subtract 1 from each value. So n is going to be something squared and something to the 19th power, and then 7n is going to be something cubed times something to the 19th power, right? And so this going there is times 7, and this going there is times this value. So that means that this value must equal 7, right? So that must equal 7, 7 squared, and 7 cubed, right? We want the greatest integer k such that 7 to the k divides n, so that's 7 to the second power, so k equals 2. Our answer is C. Number 22, a sequence of complex numbers z0, z1, z2 all the way is defined by the rules this one, where zn bar is the complex conjugate of zn and I squared equals -1. That's just to say that I is not a variable. Suppose that the magnitude of z0 equals 1 and z2005 equals 1. How many possible values are there for z0? Okay, so first of all, we need to notice that the magnitude of z is always going to be equal to the magnitude of z bar, right? So that means the magnitude of this is going to be equal to the magnitude of this. The magnitude of z and bar is just equal to the magnitude of z. So when we're talking in terms of magnitude, we can just say that this is the magnitude of zn over I zn, right? So these two will cancel. This is just the magnitude of I. And so I, if you see, it's just 0 plus 1i, and so we're going to have this as 1, right? So that means that the magnitude of all z values, this is going to be 1, right? And next, we have to notice that z times z bar, this is going to be equal to, always going to be equal to the magnitude of z squared, right? But then the magnitude of z is 1, so this is going to be equal to 1, right? And so since this times this equals 1, that means z bar is going to be equal to 1 over z, right? So we have this value, and then if we plug that into here, then that gives us that this is equal to I zn over 1 over z, right? So this is going to be over zn. So this is going to be I zn squared, right? So this is going to give us all the way down here, that's going to be zn plus 1 is going to equal I zn squared, right? And so zn is going to be if we move the I over there and then we take the whole thing by square root, that's going to be plus or minus the square root of zn plus 1 over I, right? So since this is plus minus, then we get two values of z, right? So since we have this one, we see that each zn value, each zn plus 1 gives two zn values, right? That gives two zn values, and so this means that since we have z2005 that equals 1, that means that to get to 0, we will have 2 to the 2005th power possibilities. So 2005th power choices, right? So this is our answer. It's E. Number 23, let S be the set of order triples x, y, z of real numbers for which this equals z and this equals z plus 1. They are real numbers, so there are real numbers x, a, and b, such that for all order triples x, y, z, and s, we have this being true. What is the value of a plus b? Okay, so since log 10 of x plus y equals z, and log 10 of x squared plus y squared equals z plus 1, let's say that x plus y equal m, and x squared plus y squared equal n. I had wanted to do a plus b, but then they're all taken already. So this gives us that, so m equals 10 to the zth power, right? Because x plus y is 10 to the zth power. Yeah, so that's 10 to the z power, not 2. And same thing, n is going to be equal to 10 go over there, so that's going to be 10 to the z plus 1 power, 10 to the z plus 1 power, right? And so that's going to mean that n equals 10m, right? And look, we are solving something with x cubed and y cubed, right? And so since we know what x cubed plus y cubed is, let's just write that. X cubed plus y cubed, this is going to be equal to x plus y times x squared minus xy plus y squared, right? And then since we have x plus y, that equals m, times, and then x squared minus xy plus y squared. Okay, so that's going to be, just write xy as a value of mn to n, right? So we know that xy is equal to x plus y squared minus x squared plus y squared divided by 2. And so if we put in m and n, then that's going to be m squared minus n over 2, right? So this is going to be x plus y squared minus 3xy, right? So this is going to be m times m squared minus 3 times xy, which is this value. So 3 over 2 m squared minus n, right? And since n is 10m, we can just substitute that in there. So that's going to be m minus 10m, like that. So this is going to be equal to m times, and then that's going to be negative 1 over 2 m squared, and then this times 10m, that's just going to be equal to plus 15m, right? So this is negative 1 over 2 m cubed plus 15m squared, right? And so this is going to be equal to this. But then we said that m equals 10 to the zth power, m equals 10 to the zth power, and so if we plug that into this and this, respectively, then that's going to get us that it's equal to a times m cubed plus bm squared, right? And so we can now get that since this and this are equal, and this and this are equal, right? So this is going to give us that a equals minus 1 over 2, b equals 15, right? And so a plus b equals 29 over, that equals 29 over 2. So this is going to be the answer. It's B. Problem number 24. All three vertices of an equilateral triangle are on the parabola y equals x squared, and one of its sides has a slope of 2. The x-coordinates of the three vertices have a sum of m over n, where m and n are relatively prime positive integers. What is the value of m plus n? Okay, so let's draw a diagram of this first. So this is going to be our diagram, and from this one, first it's clear that this one is not touching the x line, right? So it looks very close, but it's not actually touching. First of all, we want to get the slopes of these integers, sorry, the slopes of those lines. So the slopes are going to be they are going to be b squared minus a squared over b minus a, and b squared minus c squared over b minus c, and and a squared minus c squared over a minus c, right? So this is going to give us a plus b and b plus c and a plus c as our slopes. And then we know that one of its sides has a slope of 2, so that would just be this side, right? But then now let's just take a look at this triangle over here, right? So I'll just copy this. No, I'll just copy the whole thing, and then I'll just paste it like that. And then if I remove this parabola, yeah, so that gives us a look at the actual triangle ABC, right? And so if we move this like that, what we want to do now is move this triangle, right? We want to move this triangle so that that point becomes exactly at the origin, right? So if we do that, this is going to be a careful job. So if we move that like that, right? And so so that this is going to be touching, so this is going to be 0, 0, and so this is going to be B now, and this is going to be C now, right? And so if this is B and this is C, let's now say that this angle is theta, right? If that angle is theta, then we know that this slope is 2. So we know that tangent theta equals 2, right? And since this is an equilateral triangle, we also know that this is 60 degrees, and this is also 60 degrees. So by these, we can get the slopes of everything. So this line, that's going to be tangent theta, and then we want this one, which is also tangent of theta plus 60 degrees. Let's just say tangent theta plus pi over 3 in radians. And then we want this one, right? So this is we're not too sure about this, right? And so if we draw a line that is same as this, right? Over here, then that line would look something like this, right? So yes, so that line would be something like this, like that, right? And we would know that this angle is the angle that we want. Since this and this, they are supposed to be parallel, that means that this angle is also 60 degrees, right? And so since the whole thing is theta, and this much is 60 degrees, that means this much, that would be, yeah, so this would be theta minus 60 degrees, right? So that's theta minus 60 degrees. So our last thing that we want is tangent of theta minus pi over 3, right? And so if we get all of these and then add them, we have our answer. First of all, let's go with tangent theta plus pi over 3. So that's going to be tangent theta plus pi over 3. This is going to be equal to tangent theta plus tangent pi over 3 over 1 minus tangent theta tangent pi over 3, right? And so this is going to be equal to, since we know that tangent theta is 2, it's 2 plus, and then we know that tangent pi over 3, that's root 3, so it's 2 plus root 3 over, and then 1 minus this multiplied, so that's 2 root 3, right? And then that's just going to be, if we multiply 1 plus 2 root 3, 1 plus 2 root 3 everywhere, that's going to be all over negative 11. This is 2 plus root 3 times 1 plus 2 root 3, right? So that's going to simplify to become 8 plus 5 root 3, like that. But we don't want the negative in the denominator, so we'll just move it up to make it negative 8 and negative 5 minus root 3, right? So this is our first value. Yeah, so that's our tangent theta plus pi over 3 value. And next we'll look at this one, tangent theta minus pi over 3. So tangent of theta minus pi over 3, this is going to be equal to tangent theta minus tangent pi over 3 over 1 plus tangent theta tangent pi over 3, right? And so this is just going to be equal to 2 minus root 3, like same thing as above, and then over 1 plus 2 root 3. So this is going to be equal to all over 11, right? Because this time we multiply 2 root 3 minus 11 minus 1 onto both here and there, right? And then the upside is going to be, so the numerator is going to be 2 minus root 3 times 2 root 3 minus 1, right? And so if we simplify that, then that's going to equal negative 8 plus 5 root 3, right? So this is going to be our last value, and we have tangent theta equals 2, so now we have all our values, and we are ready to go. So the sum of these, sum is going to be equal to a plus b, a plus b plus, so the sum of a, b, and c are going to be equal to a plus b plus c plus a plus c all over 2. And so we have a plus b, b plus c, a plus c, right? So those are going to be 2 plus, and then this much, minus 8 minus 5 root 3 over 11 plus minus 8 plus 5 root 3 over 11 all over 2, right? So this is going to be equal to all over 2, and then we will have 2 plus, and then if you see here, we can see that minus 5 root 3 and plus 5 root 3 will cancel, so we will just have minus 8 and minus 8. So that's going to be 2 plus, and then negative 16 over 11, right? And then if we add 2 up there, so that's going to be this plus 2 times 11, 22, and then we're going to erase this one. And so now if we bring this over here, and then if we just make this cleaner, so bring that 11 down there, and so this is going to be 22 minus 16 over 22. But 22 minus 16, that's going to be an even number, so if we calculate that, that's going to be 6, right? And we know that 6 and 2, they can cancel, and so they will make 3, right? So this is our final answer. This is our final answer, 3 over 11. It's 3 over 11. That's m over n, right? So 3 over 11, this is equal to m over n. And what we actually wanted is the value of m plus n, right? So m equals 3, n equals 11, m plus n, this is going to equal 14, right? So this is our actual answer. M plus n equals 14. The answer is A. Last problem number 25. 6 ants simultaneously stand on the 6 vertices of a regular octahedron, with each ant at a different vertex. Simultaneously and independently, each ant moves from its vertex to one of the 4 adjacent vertices, each with equal probability. What is the probability that no 2 ants arrive at the same vertex? First, let's have a regular octahedron, like that. So that will be like that, right? And then we would have 6 ants at these places, right? 1, 2, 3, 4, 5, 6 vertices. And so for this problem, we can try to look at the cycles. Cycles, by which I mean if like these 3 ants cycle like this and like this and like this, and these 3 ants will also cycle like this and like this, and like this, like that, right? So that's what I mean by cycle. And we have 4 different types of cycles. The first type is having 2, 3 cycles. So that's just like what I mentioned before. These 3 and these 3, they are going to cycle. And so for the number of possibilities of this one, we have 4, and that's for deciding which face pair will we be going on. Will it be this face and this face that are paired? So will it be like that, or will it be like this, like that, or will it be like this, or will it be these faces like that, right? So this is for getting the pair of faces, and then multiply by 2 squared, right? That's for setting that direction of each cycle, right? And so if we have like this one and this one cycling, then this one direction, that would be 2 choices, and this one direction, that would also be 2 choices. So that's 4 times 2 squared. And then this is equal to 16, obviously. And then the next one is if we have 2 cycles, right? First of all, we would obviously have to have this one connect with one of these 4, right? So that's just 4. And so let's say it's this one that was chosen. We have 4 of these left. And now we have two choices for how to connect the leftovers, right? So that could be like that connection, or that could be a connection like that, right? So we have 2 choices for the leftover connections. So we have 4 times 2 choices for the leftovers. This is going to be equal to 8 possibilities. Third, we could have 1 4 cycle, 1 2 cycle. This is going to be, we're going to have 12 possibilities. This is because we have 12 edges from which to choose the 2 cycle, right? So we have 12 edges, and then from these 12 edges, we can choose which one will be the 2 cycle one. So let's say it's this one. Yes, so let's say that it's this one, right? That means that our 4 cycle can only go in one path, right? So and that path is going to be something like this, right? So from here to like that, like that, like that, and like that, right? So this is going to be the only path that is possible if we have one path already, right? So 12 times 1 for that one path. For this 4 cycle path, right, we have directions, right? So we can start off by going here and then go like that, or we can start off by going here and going like that, right? So we have 2 possible choices for directions. So it's times 2, right? And this is going to be equal to 24. And our last choice is, so our last cycle is if we have, so 1/6 cycle. And for that one, we have to go from the top to the middle to the bottom and then back up to the top again. Let's just generalize it like that because everything is just going to be the same. So let's just say this is the top. So from the top to the bottom and back again. First, we have 4 possibilities. This is for setting which one of these to go to, right? Because we can go to any 4. So we can go to any one of these 4 vertices at the middle line, and then from that we split. So let's say that we took this line like that, and then from here we split on where to go next. We could keep going down like that, and so at that time we will get either this way like that, or this way like that, right? So those are the only 2 ways possible, and going this way, that won't be able to reach both of them. And so we have 2 ways like that or like that, right? So we have 2 ways for that too. So we could go that way, or we could just stay along here, right? So we have 2 choices for that. We have this one and this one, right? So we have 2 choices for staying on the middle line, 2 multiplied by, right? So this is when we are going to the middle line. So let's say that we are going to this part, right? So those 2 have equal probability. That's why we said 2. And then now we have to look at how can we get from this point back to this point by crossing all of those, right? So here we can see that we have three possibilities. One is by doing this like that. Sorry, one is by doing that, and like that. So that's one possibility. And one more is going like that, down, and then up like that. And then last is going this way, like that, right? For this, first we can go like this, and like this, and like this, and then back to the top. Or we can go like this, and like this, like to the top, like that, right? Or we can take this route and then go like that to the top, right? So that's just 3 in total. So this is just going to be 4 times 2, which is going to be equal to 8. This is 4 times 2 times 3, which is equal to 24. And so this is 16 times plus 8 plus 24 plus 8 plus 24. So if we add all these, that's just going to be 16 plus 8 plus 24 plus 8 plus 24. That's going to be 80. So 80 will be our numerator, right? And the total number of possibilities that the 6 ants could go to, that's 4 to the 6th power, right? Because each ant can go 4 ways, and there are 6 ants in total, so that's 4 to the 6th power. But that is just equal to 2 to the 12th power, right? And so if we simplify that, that's going to be equal to, if we divide by 16 on both sides, we're going to have 2 to the 8th power and 5. So that's 5 over 256, right? So 5 over 256, that's our final answer. And that is choice A. So it's A. So that was it for the AMC 12A from the year 2005. And thank you for watching.